Happy Thursday, guys. Welcome to another lesson. So today we are still focusing on solving those quadratic equations, and all three of the methods we're focusing on you've learned. Remember, we're coming up to that test that you're taking next week, and so it's really important that your foundation gets a little bit more solid today. All right, so we are comparing methods to solve, and by solve, I'm talking about those roots, solutions, x-intercepts, and zeros. Okay, so the first page, you're really just looking at 3 examples that are already done for you and writing those notes. So please have some notes before going on. So just hit the pause button, do it, come back. All right. So we are talking about factoring. Now, one of the things that you should notice about factoring is that it has to be equal to 0. Be equal to 0. Okay, and then you need factors, right? So in this line, this equation is in standard form. That doesn't do it for me. Standard form. Okay, so you've got to break it down into factors. And if you use the area method, that's great, right? This person just, I think they kind of knew in their head, negative 10 times positive 4 is negative 40. And negative 10 plus 4 is negative 6. Okay, but I like doing it in the area method. And I always know my first term goes in the first box, right? This x squared. And my last term, which is the negative 40, goes in my last box. And then these two x's have got to combine to give me that middle term of negative 6x. All right, so now if I'm figuring out my factors, I know x times x. And I know I have a positive and a negative because those are the only signs that multiply to give me a negative. All right, so let me just list up my factors of 40. 2 times 20. I like going in order because then I know for sure. 3 doesn't go into it. 4 times 10. 5 times 8. 6, 7, and then we have 8. And remember, as soon as we repeat, if you've gone in order, you found all of your factor pairs. All right, so I know one's got to be positive and the other has to be negative. And if they combine to give me a negative 6, I know the bigger number has to be that negative. Okay, so 1 minus 40 is negative 39, so that's not it. 2 minus 20 is negative 18. That's not it. 4 minus 6, I gave it away. 4 minus 10 is negative 6, right? 4 minus 10 is negative 6. Ding, 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 ding. That is my middle term. So I know that these are my 2 factor terms. So I'm going to have a positive 4 and a minus 10. And that should work. So x times x gives me x squared. X times 4 gives me 4x. Negative 10 times x is negative 10x. And negative 10 times 4 is negative 40. All right, so I have everything I need. And these are my 2 factors. One factor is x minus 10. And I see that written here. And the other factor is x plus 4 written there. So that's where they got these factors. So if you guys can go and do it in your head, as long as you get it consistently correct, great. But always practice your area model because it will help you if you hit up against a problem that you can factor, but maybe it's confusing. Okay, so now here, the reason that factoring has to equal 0 is because now I can use the 0 product property. And what that says is if you've got two factors equal to 0, then one of those factors has to be 0, right? So you can set each factor equal to 0. All right, so we have x minus 10 equals 0, and then here you add 10 on both sides, and you get 0 plus 10 is 10. So this is one of your roots. And then here you subtract 4 on both sides, right? And so you get 0 minus 4 is negative 4. And remember, you should, and if I had done this on, was it yesterday's lesson or Monday's lesson, I would have realized, because my small mistake was I did the wrong sign by accident. I would have realized when I graphed that my roots were in the wrong place, right? So double check, because, even I make silly mistakes. And they're fine as long as you learn from them. Okay, so when you graph it, your quadratic should be going like that. Cool. All right. So those are some notes. 1, that factoring has to be equal to 0. 2, that it has to be in factored form. Right? So it's got to be in factored form. If it's in standard form, you got to change it so it's in factored form. So I'll kind of put both of these as number 2. All right, and then 3, you've got to use that zero product property rule. All right, so the next one, so some notes that you should take when completing the square. Now, completing the square just means you have got to get a perfect square trinomial alone on one side of the equal. So I need a perfect square trinomial on one side of the equal, and that needs to be alone. So that's the goal. So this does not have to equal 0. The important thing is that that perfect square trinomial is all by itself on one side of the equal. Okay, so we look at this, and I just want x squared and the x term on the same side as on the same side of the equal sign. Sorry. All right, so now remember, the whole goal is to make this into a perfect square trinomial, and it's not yet. So far I have the x squared, and then I'm going to split the negative 18 in half. So negative 9x's go here, and the other negative 9x's go here. Remember, they've got to be identical. We're creating a square here, guys. So I've got x squared in my box, and I've got negative 18x in the form of 2 negative 9x's. All right, so when I'm doing my perfect square, remember I need to have the same exact identical thing on the top and the side. So x times x gives me x squared, and now x times negative 9 will give me negative 9x. Same thing down here. Okay, negative 9 times x gives me this negative 9x. So now, what do we need to complete this square? Okay, so hopefully you have it. All right, negative 9 times negative 9 is a positive 81. So if you notice, they have that here, right? A positive 81. All right, so now I have a perfect square trinomial. Remember, I said that is what I needed, this perfect square trinomial. All right, so the whole point of complete the square is not to get it to equal to 0. It's not to factor it. It is to complete this square. So now that I have this perfect square trinomial, I can rewrite it as x minus 9 times x minus 9, or x minus 9 squared. All right. So once x minus 9 squared is by itself, if you notice the 16 is on the other side of the equal, then I can square root both sides. So I use the square root method, not the zero product property here, right? There's no zero on the other side. So this is one important thing to note. And then 2 is I use the square root to solve it. Okay. Cool. So this square and square root canceled out and gives you x minus 9. And then the square root of 16 is either a positive or a negative 4. Remember, 4 times 4 is 16. And negative 4 times negative 4 is a positive 16. So 9 plus 4 is 13. And, oops, that always happens when I get close to the edge. 9 minus 4, remember it's both a plus and a minus 4. 9 minus 4 is 5. And I also notice that this is in set notation. Right? It just means that x is everything inside these like kind of curly brackets. All right, so I would be interested if you noticed anything else. Feel free to email me. But those were the main things that I noticed. Okay. All right, quadratic formula. Okay, so remember, this one has the most steps. Do you remember what this is called? Think about it. Okay, starts with a D. Discriminant. Okay, so the quadratic formula is negative b plus or minus the square root of b squared minus 4ac divided by 2a. All right, so remember the discriminant is just this part. The b squared minus 4ac. So in this particular problem, the discriminant is 45. So do you guys remember from that lesson how many roots you would have? So remember, it's a positive 45. Now, if you don't know, then you should just solve it, right? Or graph it, okay? But if this is a positive number, then that means you have 2 real solutions. And I see here that I'm going to have negative 3 plus 3 square root 5 divided by 2, and negative 3 minus 3 square root 5, and then divide that by 2. Okay, so you will have 2 real solutions here. I think the only other thing I'm going to do is when you have your standard form, remember that is ax squared plus bx plus c. So in this particular problem, my a value is the one in front of x squared. So my a would be negative 1. And I do see a negative 1 where the a value should be, right? Both here and here. Okay. B is the coefficient to x. So that's negative 3. And yeah, every time I see b in my equation, so here I see negative 3. And here I see positive 3. So why is that? All right, we'll come back to that. All right, and then C is the number by itself, which is 9. And I see C only one place here, the 9. Great. All right, so I don't know if you guys figured it out, but if I were to replace this b with a -3, I have two negatives, right? So a negative from the formula and a negative because the b value is actually a negative number. So negative times a negative gives you that +3 right there. Okay, so I think that's all the notes that I can see. So it's really important that, one, you know the formula, right? So let me change this back to a -b. And not that you memorize the formula, just that you know what it is and that you can Google it, that you can look for it on the Regents if you take that. Two, what the discriminant is, right? So, and what that means, that a positive means you're going to have two answers for x. And also where you get the numbers, right? So you can only get the numbers if you're in standard form and if they're all on the same side of the equal value or of the equal sign. Okay, so if you have any of the terms on the opposite side of the equal sign, it'll throw off your signs. You'll get the wrong answer. Okay, so everything has got to be on the same side. All terms on the same side of the equal. All right, so now I'm just going to do one problem with you guys. And let's see, this is a fun game, if I will run out of room. All right, so I wrote it up here so you can see it a little bit better. So with factoring, it's got to be equal to 0, and it is. Fantastic. So now what I'm going to do is I don't like having a number other than 1 in front of my x squared. So I'm going to actually just take that out as like a greatest common factor. And -1 times x squared gives me -x squared. -1 times a +6x gives me -6x. And -1 times -16 gives me +16. Okay, so I've kind of factored it a little, but I want it to be broken into like those two parentheses. All right, so I'm just going to do, maybe I'll do on the bottom here and see if that gives me enough room. Of course it doesn't. Okay, so let me make that a little bit bigger. All right, cool. So first term goes in the first box. Last term goes in the last box. And these two diagonal boxes have got to combine to give me 6. All right, so I know I have x times x. And if I'm multiplying to get a -16, I know I've got to have two different signs. So now, let me see. And the bigger number should be a positive because I see when I combine them, I need to have a positive. All right, so 1 times 16, right? And the bigger number should be positive. Okay, so, and then 2 times 8. 3, no, 4 times 4. Okay, so -1 plus 16 is 15. Nope, I'm looking for 6. -2 plus 8 gives me, oh, that gives me 6. All right, cool. And -4 plus 4 would give me 0. So I'm not looking for that either. All right, so I'm going to have -2 here and a +8 there. All right, so now let me finish this. It's not a perfect square, but it's like a rectangle, kind of. So x times -2 is -2x. And 8 times x gives me a +8x. And when I combine these guys, 8x minus 2x, I get 6x. Cool. So my factors are x minus 2 and x plus 8. X minus 2, x plus 8. Okay, so now I've factored it. I'm going to use zero product property rule. And so I'm going to set x minus 2 equals to 0 and x plus 8 equals to 0. So when I add 2 on both sides, I'll get x equals 2. And when I subtract 8 on both sides, I will get x equals negative 8. Okay, so my two factors, I can say that, are x minus 2 and x plus 8. My two solutions are x equals 2 and x equals negative 8. That's where they're going to cross the x-axis, right? Okay, so now completing the square. I have the same exact problem. Okay, and now I only care about these guys. Okay, so I'm going to actually say goodbye to this 16. And I'm going to say negative x squared minus 6x equals negative 16. I'm going to actually change colors. All right, now again, I don't like that negative being in front of x squared. I want it to be a 1. So if there's any number other than 1 in front of x squared, I'm going to divide every term by that negative 1. So that cancels out, leaving me with x squared negative 6 divided by negative 1 gives me a positive 6x. And negative divided by negative gives me a positive 16. All right, so I'm going to use the quadratic space for a little bit just to do my perfect square. So again, first term, first box. The x terms now get evenly split between those two diagonal boxes. So if I've got 6, that divides evenly into 3 plus 3. 3 plus 3 is 6. All right, so now I'm going to say, all right, x times x is x squared. And now x times 3 gives me 3x. And the same thing here. Remember, I'm making a square, and then I've got to complete it here. This is where I'm completing it, right? Because I have x squared. I have 6x because 3x plus 3x is 6x, but I need something else to complete it. And that number would be 3 times 3 or 9. So I'm going to add 9 here, and I'm going to add 9 here. So now I have x squared plus 6x plus 9. There's my perfect square trinomial, looking beautiful. And then 16 plus 9 is 25. All right, so now my perfect square trinomial can turn into x plus 3 times itself. So I can write that as x plus 3 squared equals 25. And let's square root both sides. So I get x plus 3 equals a positive or negative 5. Remember, 5 times 5 is 25. Same with negative 5 times negative 5. All right, so now I'm going to subtract 3. I'm coming right to the edge of it. And so I have x equals 5 minus 3 is 2. And negative 5 minus 3 is negative 8. And if you notice, that's exactly the same x-intercepts or roots that I have in factoring. All three of these methods should give you the same exact answer. All right, so now quadratic formula. Now, do I have standard form all on the same side? I sure do. So in quadratic formula, just like factoring, you got to get everything to one side, right? So you got to get it equal to 0 first. All right, now I know A is -1. Why do I keep using the same color? Okay. A is -1 because that's the coefficient to x squared. B is -6. And C is 16, the number by itself. All right, so now I have x equals -b plus or minus the discriminant, which is b squared minus 4ac, divided by 2a. All right, so now every time I see a, I'm going to erase that and replace it with a -1. So this was -4 times a -1. Okay. And now every time I see C, I'm going to replace that with 16. Okay. And every time I see B, I'm going to replace that with a -6. So -6. And remember, this is like the other example where it's a negative. So I have x equals +6 plus or minus. Good thing I have my calculator here. And I'm going to find out what that discriminant is. So parentheses 6 squared, or sorry, parentheses -6 squared minus 4 parentheses -1 parentheses 16. Ooh, and that gives me an even 100. And it's a positive 100, so that tells me that this is going to give me 2 answers. All right, and 2 times -1 is -2. So that gives me 6 plus or minus 10. Remember, square root of 100 is 10, divided by -2. All right, so x equals 6 plus 10 is 16, divided by -2 gives me -8. And 6 minus 10 is -4, divided by -2. -4 divided by -2 is a +2. So again, same exact answer as the other 2 methods. All right, so will you have to do all of these methods? No, but you do know, so 2 things. You don't have to use the same problem to do all 3 methods other than on today's worksheet, but you can choose. You can say, hey, I want to do complete the square. I want to do factoring. You can choose the one that fits the best in whatever problem that you're on. Okay, and you can use the others to check, right? So that's pretty cool. All right, so questions, concerns, comments, you guys know what to do by now. We are about to head into the very last marking period of the school year. All right, so reach out. Any questions, concerns, comments, we are here for you. I will see you for tomorrow's lesson. Bye, guys.